Inflation is the steady process that reduces what your money can buy even when the numbers printed on your bills and bank statements stay the same or even grow. Many people sense this happening long before they understand the mechanics. You finish a normal grocery trip and realize the total is higher than it was a year earlier even though you bought the same items. Your rent increases by more than you expected. The car that once cost $25,000 now costs $35,000. Over time, these small changes add up and create a feeling that your income is not keeping pace with the cost of living. The purpose of these 10 animations is to make that process visible and measurable so you can see exactly how prices move and what that movement does to the money you already have. The central relationship is straightforward once the quantities are named clearly. Inflation is the rate at which the average price level of goods and services rises over a period of time. When the price level rises, the purchasing power of each unit of currency falls by a corresponding amount. If prices rise by 4% in 1 year, then $100 at the beginning of the year will purchase only what approximately $96 would have purchased 12 months earlier. The calculation is direct. You take the original amount and multiply it by 1 minus the inflation rate. In this case, 100 multiplied by 0.96 gives the real value after 1 year of 4% inflation. The first animation shows a single amount of money losing purchasing power across 2 decades. Begin with $100 held in the year 2005. At a steady inflation rate of 3% per year, the real value declines each year. After the first year, the purchasing power falls to $97. After 5 years, it drops to roughly $86.50. After 10 years, the original $100 is worth only $74 in 2005 term. After 15 years, the value has fallen to $64. After 20 years, it reaches approximately $55.30. The animation displays the original bill gradually shrinking while the years advance along the bottom of the frame. Each step reveals how repeated 3% increases compound into a substantial loss, even though the nominal number of dollars never changed. The second animation follows a typical household shopping basket containing milk, bread, eggs, chicken, rice, and vegetables. In the base year, the total cost of this basket is $40. Each year, the prices inside the basket rise by an average of 3.5%. After the first year, the basket costs $41.40. After 3 years, the total reaches $44.20. After 5 years, it climbs to $47.30. After 10 years, the same basket costs $56.20. After 15 years, the cost reaches $66.70. The animation labels each item and shows the price tag next to it rising year by year. The cumulative effect appears even though no single item doubles in price overnight. The steady application of the same percentage increase to the entire basket produces the final result. A third animation compares salary growth with price growth over the same period. A worker begins earning $50,000 in year 1. Each year, the employer provides a 3% raise, so the paycheck rises to $51,500 in year 2 and continues increasing. At the same time, the price level is also rising at 3% per year. When the two lines are shown together, the nominal salary line moves upward, yet the real purchasing power line stays nearly flat. After 10 years, the paycheck has grown to $66,900 on paper. However, the goods and services that $50,000 could buy in the first year now require almost the same real income to obtain. The animation makes the gap visible by showing both lines on the same graph, So the difference between nominal growth and real growth becomes clear. The fourth animation demonstrates what happens when the central bank increases the money supply. In the starting year, the total money in circulation is $1 trillion and supports a certain price level for the existing goods and services. Each year, the central bank adds new money at a rate of 5%. After the first year, the money supply reaches $1 trillion and $50 billion. After 5 years, it grows to $1 trillion and $276 billion. Because the quantity of goods and services has not increased at the same rate, the price level must rise to balance the larger number of dollars. After 5 years at this rate, the price level has increased by approximately 28%. Each existing dollar now represents a smaller share of the total goods available. The animation shows the money supply expanding while the value of each individual dollar visibly shrinks. The fifth animation examines savings held in a basic bank account. A person deposits $10,000 in an account that pays 1% interest annually, while inflation runs at 3%. After the first year, the nominal balance reaches $10,100, yet the real purchasing power has already fallen below the original amount. After 5 years, the account shows $10,510, but the real value has dropped to approximately $9,050 in starting year terms. After 10 years, the nominal balance reaches $11,046, while the real value has declined to roughly $8,220. The animation displays two lines moving in opposite directions. One line shows the growing nominal balance, and the other shows the declining real balance measured in constant purchasing power. The sixth animation compares price growth with wage growth when inflation rises faster than wages. In a moderate period, both prices and wages increase at 3%, so real living standards remain stable. When inflation accelerates to 6%, while wages only rise at 4%, the gap widens quickly. After the first year at the higher rate, the real wage has already fallen by nearly 2%. After 3 years, the cumulative loss reaches approximately 6%. After 5 years, the real wage has declined by almost 9%, even though the paycheck number continues to rise. The animation shows the price level line pulling ahead of the wage line, making the erosion of purchasing power visible over time. The seventh animation illustrates how changes in interest rates can influence the inflation rate itself. When the central bank raises the policy interest rate, borrowing costs increase for businesses and households. Higher rates reduce spending and slow the growth of credit and the money supply. If inflation had been running at 5%, a sustained period of higher interest rates can bring the rate down toward 3% over roughly 2 years. The animation shows the inflation rate line beginning to bend downward after the rate increase, while the price level itself continues rising, but at a slower pace. The mechanism operates through reduced demand rather than through direct control of individual prices. The eighth animation traces the effect of a supply shock through the economy. When the supply of a key input such as gasoline or wheat falls because of weather, conflict, or production problems, the price of that input rises sharply. A 20% increase in energy costs can push the overall price level higher by 1.5 to 2.5 percentage points for several quarters. The animation follows the price increase from the specific good outward to other goods that use the same input, showing how the effect spreads through the broader basket. The ninth animation returns to personal savings, but compares two different inflation rates side by side. The same $10,000 is shown under two scenarios. In the first scenario, inflation stays at 2% per year. After 10 years, the real value of the savings falls to approximately $8,170. In the second scenario, inflation runs at 5% per year. After the same 10 years, the real value drops to roughly $6,140. The animation places both outcomes on the same screen, so the difference in lost purchasing power becomes unmistakable. The higher inflation rate produces nearly twice the real loss over the same period. The 10th animation shows the effect of very high inflation over a short time. Prices begin rising at 20% per month. After the first month, the price level has increased by 20%. After 3 months, it has more than doubled. After 6 months, it has increased by more than 3 times. Wages and savings cannot adjust quickly enough to keep pace. A monthly salary that once purchased 100 units of food now purchases fewer than 30 units after 6 months. The animation compresses the time scale to reveal how rapidly purchasing power can collapse when inflation reaches extreme levels. These 10 visual explanations together demonstrate that inflation is not a single event, but a continuous process driven by the relationship between the money supply and the supply of goods and services. When the money supply grows faster than output, prices must rise to restore balance. Each percentage point of inflation compounds over time, steadily reducing what a fixed amount of currency can purchase. Salaries that rise more slowly than prices produce a decline in real living standards, even when the paycheck number appears larger each year. Savings lose real value whenever the interest rate earned falls below the inflation rate. The animations make these relationships visible rather than abstract. The practical implication is that protecting purchasing power requires deliberate choices rather than passive holding of cash. Investments that have historically delivered returns above the inflation rate become necessary tools once the mechanism is understood. Adjusting saving and spending habits to account for rising prices is equally important. The difference between ignoring inflation and responding to it can represent tens of thousands of dollars in lost buying power over a working lifetime. The 10 animations show the cost of an action in concrete numerical terms rather than as a vague concern.